Okay, all right. So in this question, an archer pulls her bowstring by an amount of 0.40 meter. Okay, and this is done by applying a force that increases from 0 Newton to 230 Newton. Okay, all right. So we have to calculate the equivalent spring constant of the bowstring. Okay, and what work she does on the bow. Okay, so work done. So the spring constant K is related to the force by this equation, F equal to Kx, right? Now to calculate K, let me solve this for K, right? So we can write K is equal to F over X, right? So for X equal to 0.4 meter, the force is 230 Newton. So if you substitute this, you can write 230 Newton over 0.40 meter, and that is just 575 Newton per meter. Okay, so this is the spring constant for the bowstring. Now we have to calculate the work done. Okay, so to calculate the work done, let me just draw force versus x. Okay, I mean force versus displacement graph. So this is force and this is displacement in meter, right? So force, and the force is in Newton, right? And from the given information, you can draw a graph something like this, right? And that is 230 Newton, and this is 0, right? And this is 0.40 meter, right? Because the question says that the force increases from 0 to 230 Newton between 0 meter and 0.4 meter, right? So that is just a straight line. Okay, so then you know that the force, I mean when we have a force and a force versus displacement graph, the work done is just the area under the graph. Okay, so area under the graph is this part, right? So we have to basically calculate the area of this triangle, right? So what is the area of this triangle? That is half time base times height, right? And that is, the base is just 0.04 meter, right? This is 0.04 meter, 0.40 meter, and height is 230 Newton, right? So this is 230 Newton. So if you multiply half times 0.40 meter and 230 Newton, you get 46 joule. Okay, so she does